Just a quick statistical review and why it matters when we're doing analysis, specifically analysis on throughput. Our end customers love to hear, you will get X, and we can't guarantee they're going to get X. We can't even guarantee, based on Vladan's little thing, you're going to get neg 67 here. Well, 75% of the time you might get neg 67 there. But even if you get neg 67, what modulation are you going to end up using? And that's a decision that the client makes based on what he sees at the moment. So same RSSI, same number of spatial streams could result in a wide range of different things. Well, if we look at just min, max, and averages, this is just a set of data I put together with 25 data points to exaggerate an issue. And the issue looks something like this. If I have two sets of data, they both have identical averages. And if you look at them in this form, you go, yep, green line, blue line, same min, same max, same average. But they have a different standard deviation. And as soon as I say the word standard deviation, and probably when Vladan's little thing had the little standard deviation symbol, your eyes glazed over and went, I don't want to talk about that. But it matters. If we take the same two sets of data and we sort them first, rather than just leaving them random, we sort them from high to low. These two sets of data have the same average, but they're different. One has the red line has a very consistent set, even though they average out to the same place. The red line's more consistent than the blue line. Which one would you want to have for your throughput test? Red or blue? Okay, that was, were you supposed to raise your hands? Red or blue? Carter, it's a choice. I mean, it's like red, blue. He's over here going, I don't know. So what we're after is not just the data we collect, but of the data we do collect, how can we show it so it shows a little better information? Something that we can then talk to our customers and say, this solution we gave you is more stable. We have a more stable solution than one. They both give you the same average. One's just a better solution. Another thing I wanted to drop off, and by the way, these are just things I had on my website just to go pull up. This one is, we're having a discussion the other day about Proxim 84, 94s, and consistency. So I did a test. It was a very rainy day. Somehow when I get stuck in rainy days in hotels and I can't go anywhere, I do weird tests. One, I was in Vilnius, and I came up with a test between baseline and another thing. This one was in Jakarta on a rainy Sunday. And I had a bunch of NICs with me. I had 15 NIC 8494s. And I've been trying to use the same NIC, the same label, and the same position for a long time to be. But I wanted to say, well, I say that, but let's get some data. So we took them and I set it up with a system where I could gather 2,000 pieces of information in a 2-minute period. That's a lot of data. So you're going to see on the screens, they're really close together. And it looks something like this. So I took 3 NICs and put them in a USB hub. They're about 5 centimeters apart, 1, 2, 3, so about that far apart, and ran their data sets. Are they consistent? Well, I'm looking at it going, well, B and C, and those were positions B and C. Oh, by the way, to make sure that this was there, I went down to the front desk and got some tape, and I taped the USB hub to a spot on the desk so it didn't move. I put the AP on a place and then taped it down so it didn't move. And I moved so that my body was in between the two sets so nothing was interfering with this data. And obviously about a 5 dB average difference. And I went, oh, I wonder if it's the NIC in A or the position of A. So I reran the data again. And here is the data, and I moved them and rotated them around. And I moved them to reverse. So Now it's C, which was used to be in position A. So when sorry, wrong way. So here, number 1 was in the A slot. Here, number 1 was in the C slot. Pretty obvious that now we have, oh, it's that nick. It's not the position. Well, what if I test all my nicks? Well, realizing I'm thinking maybe there's a position might make a difference. Let's do now this is what took a long time. I only used one position. And I retested all 15 A nicks over and over and over, and each of them was in the exact same position. 2,000 data points. And so nick C is about 7 dB lower than nick A. And as you look at these, they're not consistent. They're same brand, same nick. A bunch of them are within one MAC address of each other. They're consecutive because I bought them as a group. And we look at that and go, yeah. So what do we do about it?
Buy a sidekick.
I mean, yeah, that Sidekick's trying to address this issue, but everybody can't buy a Sidekick. So what can we do? I mean, that was an actual legitimate question. Divide it by 3. So which nick should I be doing my tests on?
3 of them.
Which 3?
Select 3.
Select 3 and then, yeah. So I had this one nick that was my primary nick that I had been using for a long time. And it had a label on it. I labeled it instructor, and it was the one I would test with because it was my best one. I'd done this test earlier, and it was that, yeah, I want it. And then it ran into a door one day, all by itself. It just jumped out and hit the door. I don't know how it happened, but it now has a little rattle to it. And they're not supposed to rattle. And see if you can see which one it is. It's C. The one that was my favorite. And now it's like 5 dB lower. Like, do I use it or not use it? So when we're testing, we live in these worlds of absolutes. We're going to measure to neg 65 on primary, neg 67 on secondary, and have an SNR of 25. And if we even miss it up, we're not going to, TAC won't even answer our call because they say, you're not meeting Cisco specs. And we're down in these precision numbers, and yet our nicks are floaty, floaty, floaty. So know your nicks and compare yours. And then the best we can hope for is to compensate. We can't calibrate these nicks. There's no calibration possible. Even on the Sidekick's production process, they don't calibrate. They compensate to a gold standard. We just don't have them in our industry. It doesn't matter if it's these or the ones inside your laptops. We ran a test at WOPC in Phoenix. iPhone 6, iPhone 6, iPhone 6, iPhone 6 with a standard deviation of 5 dB. That's the standard deviation. That means they had a 10 dB swing, same brand, same nick, on a same jig placed on the same table in the same orientation. And we're out there telling our customers, I'm gonna guarantee your. And then our customers say, well, we want all phones, all laptops, anything that's ever Wi-Fi to always work. So we live in this world of absolutes and non-absolutes at the same time.